expression to represent the length of the path described by parametric equations. You've got an x equals, you've got a y equals. We want the time between 3 and pi over 2. Guys, this is really a formula quiz, all right? What is the length of a path? What is the length of a path? What's the formula? The integral of, from t1 to t2, the square root, okay, dx dt is in here, squared, plus, okay, dy dt squared, okay, and it's a dt problem. It's important that you remember it's dt, because if you do this problem, since this is a t, these limits must be t. But if you remember these limits are t, then you're in pretty good shape. Remember, this formula is the exact same formula, but you got to use it correctly as the formulas that go from x1 to x2. But if you go from x1 to x2, you have to use a different formula, ones without t. Okay, so you can do either one you want, but you got to make sure you're putting the right thing into these parts of the formula. All right. Okay, so let's go. We do have parametric, so we're going to use this equation. And so what we have is the easy part is we have T1 and T2. We don't always have T1 and T2. Sometimes they'll say something like, I think this was the last problem on your quiz actually. They'll say something like, the time is when you cross the x-axis. If they say the time is when you cross the x-axis, then it's no longer these times. It's the time when what is 0? When crossing the x-axis is when y is 0, right? And then I think maybe your quiz was, it's a time when you cross the y-axis. Okay, so if I say it's a time when you cross the y-axis, then what do you set equal to 0? Your x equals 0. And then you would find a time from that, okay? But here, it's not too bad. They tell you the time, okay? So you just plug it in here. And here's the hard part here. What is dx dt? You know x is equal to cosine squared t. Hopefully you know that that is really cosine t quantity squared, because so many students don't know that, or they won't rewrite it. They refuse to rewrite it. And if you refuse to rewrite it, what happens is, when you tell me dx dt, you'll tell me that this is equal to 2 cosine t, okay? What teacher taught you that, okay? It actually isn't 2 cosine t. Does anybody have any idea what I did wrong? I didn't do the chain rule correctly. Okay, because it's 2 times 1. Bring down the inside, take the power down by 1, and take the derivative of the inside. Okay, so this dx dt, you would plug in as this thing over here. I don't have room, so let me pull my stuff over, and let me write this. This will be 0 to pi over 2, the square root of negative 2 cosine t sine t quantity squared plus. All right, now let's find dy dt. I helped you find dx dt. You do it on your own. Find dy dt. Go for it. Go ahead and jot it down. Because I want you to make the mistake now. It's way better to make the mistake now, okay, than to make the mistake on your test. What is dy dt? Okay, hopefully you've jotted it down. And the derivative of sine t cubed, which is really sine t quantity cubed, is 3 times sine t. Bring the power down by 2, but don't forget, take the derivative of the inside, all right? So this goes right in here. This is 3 sine squared t cosine t quantity squared dt, and I'm done with my problem if I did it right. Okay, and if you want to, you can distribute this square, right? Each factor would get squared. But if you don't want to take a chance, I'm good with leaving it like this on the test. Of course, unless it's a multiple choice, then you need to know how to square it correctly. I want you to draw a triangle if there is not one there, okay? And we're going to develop some formulas off of this triangle. These formulas that you already know from geometry, okay? This distance is going to be x, this distance is going to be y, and we're going to call this our hypotenuse, we're going to call it the radius. Okay, this is just like the unit circle, except for r is not a unit, it's going to be r, okay? And what we're going to do is, from this right triangle, we know a lot of things from geometry. We know cosine theta is actually adjacent over hypotenuse, right? So for this triangle, okay, it's actually x over r. We know that sine theta is actually opposite over hypotenuse. So for this triangle, it's actually y over r. And then we also know tangent theta is actually opposite over adjacent. So for this triangle, it's going to be y over x. It's going to be the y distance over the x distance. All right. And then we also know from the Pythagorean theorem that x squared plus y squared is equal to r squared. Okay. So what you'll do is you'll need to not just memorize this, but be able to like spout it out. Okay. Because if you forget how to convert, it's just one of these equations. Nothing hard except that like you'll forget to spout it out. Like you'll forget that you know it. Okay. We use this, but actually a little bit more than this formula. We use this formula a little bit more. X is equal to r cosine theta. And we use this formula, but a little bit more than this formula for polars. We use y is equal to r sine theta a little bit more. The tangent theta stays just like that. This one, sometimes we use r is equal to the square root of x squared plus y squared. Okay. So your first problem says you've got some coordinates and you want to convert them to rectangular coordinates. Okay. So you gotta use Jedi mind tricks. Okay. And what that means is you gotta like know what your enemy what your enemy wants. Like what do they want here? What do you want? Like what's your goal here? What's your goal here? You want rectangular coordinates. X, Y. So you really want X, Y. Does that make sense? Okay. So if you want X, Y, let's think about what we have. What do we have? If this is rectangular, what must this be then? Polar. If this is polar, what's calculus talk for your 2? What's that really? R. And if this is polar, what's calculus talk for 5 pi over 6 really? Theta. Okay. So if you want X and you want Y, what formula relates X and Y to R's and thetas? X is equal to R cosine theta and Y is equal to R sine theta. And then this is really just a plug-in. So X is equal to, what's your R? 2. What's your theta? 5 pi over 6. Okay. Y is equal to, what's your R? 2. What's your theta? 5 pi over 6. And this is your answer. You just need to simplify it. If you go look on your unit circle, at 5 pi over 6, what is my cosine value? Negative square root of 3 over 2. So that means x is equal to negative square root of 3. Okay. On your unit circle, what is sine 5 pi over 6? 1/2. Okay. So y here is really equal to 1. So what are our rectangular coordinates? Negative square root of 3, comma 1. Okay. Moving from polar to rectangular coordinates is the easiest thing to do. All right. So let's get a little bit more difficult. We're going to do the opposite. We're going to move from rectangular to polars. Okay? It's going to get a little bit harder. And let's think about this. Let's think about our goal. Okay? What is it that we want? Polar. What does polar look like in calculus talk? R, comma, theta. Okay, now that we know what we want, let's think about what we have. If these are polar coordinates, then these must be rectangular coordinates. Think about calculus talk. Then what is your 3 really? X. What is your negative 3 really? Okay, Y. All right, so I've got X, I've got Y. I want to move it to R and theta, okay? The way you do this is different from the way we did moving polar to rectangular. What you do is you use your tangent formula and you use your Pythagorean theorem formulas. Okay, just use different formulas to help you out here. Okay, your tangent formula here, because we want to keep the theta, right? We want theta. So what's y over x here? Negative 3 over 3, which is just negative 1. So what I have is tangent theta is negative 1. If tangent theta is negative 1, I don't really want tangent theta. What do I really want? Theta. Okay, how do I move from tangent theta to theta? Yeah, it's an inverse tangent, arctangent of both sides, right? So the question is, at what angle is my tangent value negative 1? So remember, this is positive, positive, negative, positive, positive, negative, negative, negative. So there are two places, right? Here and here. Okay, and for those of you guys who are like, okay, yeah, that is exactly right. It was there. Okay, but those of you guys who are like, okay, wait, isn't arctangent here? Or was it here? I forget. It's here. Okay, that's actually not how you would do this problem because it's not an arctangent problem. Like nowhere did it limit you that you had to, it had to be, how do I say it? That theta had to be limited between negative pi over 2 or pi over 2. Like had it been an arctangent, yes. But this is just saying tangent theta is -1. So you actually have an infinite number of answers. Okay. So let's talk about this. Which one would I pick? Okay, and how do I know which one I would pick? What you do is you go back up here and you say, remember, this is like a polar graph. And on top of this polar graph, a rectangular coordinate sits on this. And my point is at 3, -3. So if my point is at 3, 3 over, 3 down, which quadrant would I be in? The fourth quadrant. So you need to pick the angle that's in the fourth quadrant. Do you remember this from pre-cal? Kind of? Okay, so you need to pick this angle here. But what is that angle right there? Do you remember? It's 7 pi over 4. Okay, and that's how we get the angle. The r's are actually pretty straightforward. You would just say x squared, which is 9, plus y squared, which is 9. So this is the square root of 18. If you wanted to leave it as the square root of 18, you could. But if you had a multiple choice test, you might need to know that this is really the square root of 9 times the square root of 2, which is just 3 square root of 2. All right, so this will be equal to 3 square root of 2, comma, 7 pi over 4. And that one's a little bit more difficult to do. All right, so we've done conversions between coordinates. Now what we're going to do is we're going to change to conversions on equations. Okay, so now we're just looking at equations. And if you think about it, what we're going to do is we're going to say, if you graph this, okay, what would be the equivalent r equals graph? Does that make sense? Or if you graph this, what would be the equivalent r equals graph? Okay, so let's look at this one. We want to convert it to polar, so it's obviously rectangular. What's another word for y? Do you remember in polar form? R sine theta equals 4. I'm basically done. Right? I changed everything to r thetas. No more x's and y's. Okay. A lot of times you wouldn't see it like this though, because a lot of times, just like when you see a y equals equation, a lot of times in polar you'll see an r equals equation, and so you might see something that looks more like this than you would, like this first one. They're both basically the same thing, but a lot of times they change it to r equals. Okay. What that means though, which is kind of interesting, what that means is if you graph this, it looks exactly like this graph. Okay, so if you graph this, how do you graph y equals 4? What does y equals 4 look like? Is that y equals 4? This graph, believe it or not, is going to look just like this graph. Well, how do you graph this graph? Well, you would just do a theta r. You did this last night, okay? And you would do r equals 4 cosecant theta, okay? And then you would just plug this in, and actually what happens is you would get points that are actually like all linear, and it would actually be a linear graph, okay? You'd also get a headache, okay, but you'd also get that line. So if you want to, you can go home and graph this. You know how to do it, and you'll get points that look like that. All right, what about this side here? How would I change this to polar form? Change it to r's or thetas. How? X is r plus 1. Say it again.
X cosine theta.
Okay, so x is r cosine theta. So this is r cosine theta squared plus r sine theta squared is equal to 25. Oh, isn't x squared plus y squared equal r squared? So you could do that. Are these the same? It should be. Well, let's see. What if I squared this? Wouldn't this be r squared cosine squared theta plus r squared sine squared theta equal 25? What if I took out the r squared? Wow. How does this end up looking like this? Okay, what's cosine squared plus sine squared? 1. So they're basically the same. Okay, But you could leave it like that. It's not bad, but really, usually you do R equals, okay? And even more than R equals plus or minus 5, usually you would just see R equals 5, because if you graph R equals negative 5 and R equals plus 5, you would get the exact same graph, okay? What does R equals plus 5 and R equals negative 5 look like while we're talking about it? It's a circle with a center at 0 and a radius of what? 5. Guys, is this a circle with a center of 0 and radius of 5? Wow. You want to say it together? Wow. Okay, that was incredible. That was a moment. Okay, all right, let's look at this one right here. First, what we want to do is convert r sine theta equals 3. Now we're going from r's and thetas into x's and y's. How can I change this to x or y? It's done. Y equals 3. Okay, and if you want to graph it, it's done. Okay. All right. What about this one right here? This one's not as nice. If the cosine had been on this side, then it would have been okay. Okay. If the cosine had been in here, we could have said this was x equals 2. Is everybody good with that? But it's not. Okay. So you have to do something a little bit different with this one. It's a little bit harder. So our goal, remember, is get rid of all the r thetas. Okay. We want only rectangular form. We only want x's and y's. So what can I replace the r with? What can I replace r with? Okay, square root of what? X squared plus y squared times 2. What can I replace the cosine theta with? And guys, and all these are short ways to do it and long ways to do it, but it doesn't matter. Like if you are putting in things that are equal, you're totally fine. You just manipulate the algebra. So what's another way to say cosine theta? X over r. Okay, good. So remember, our goal is to get rid of all the r's and thetas. So let's keep on going. X squared plus y squared is equal to 2x over, what can I replace the r with? Because I only want x's and y's. I hear a lot of moaning, but I don't hear that what I should do. Are you guys good with that? Okay. Now, what happens now? If you cross multiply, look what you get, which is kind of cool, because if you remember this from, I think, your geometry days, okay, if I bring this negative 2x over, so just FYI, I'm going to bring the 2x over, that turns to a negative 2x. And if I complete the square here, what would be the magic number? Think about it. 1. If I add 1 on this side, I have to add 1 on this side, okay? If I complete the square here, I mean, the whole reason to complete the square is that you can get a perfect square. What kind of a picture does this give me? Do I need to pull it up some? What kind of picture? A special ellipse, an ellipse, but a very special ellipse, because it has no denominators. It's a circle. Where's the center of this circle? 1, 0. What's the radius of this circle? 1. Okay. So to draw this right here, I would plot 1, 0. That's my center. I guess you wouldn't really plot it, but that's my center, 1, 0. Then you would make a radius of 1. Okay. Is the radius 1? Yeah, you make a radius of 1. Did I do that right? Something like that. Okay, radius of 1, and that's my circle. Well, let's think about that. What that means, though, is this expression up here, okay, is actually a circle with a diameter of 2. Do you remember this from Polar last year? A diameter of 2. And we'll talk more about this sort of notation tomorrow. Okay, let's look at one of the harder problems. This problem right here. Actually, I want to just delete this. Okay. If you just have theta equals something and you need to graph it, just like when you have r equals 5 and you need to graph it, you would just say it's a circle with radius 5. Okay. If you have theta equals something, what you do is you find that angle. So if the angle is 2 pi over 3, remember, you always start the horizontal for your, I guess, your base. There's probably a word for that. But you always start the horizontal line to start with 0 degrees, okay, or 0 radians. And then we're going to move 2 pi 3. That's your angle. And if you draw the line like that, that's how you draw theta equals 2 pi over 3. Okay? You can memorize it if you want, okay? But you can do a check on it by changing this to y and x's. So what we need to do is change this to rectangular form. And this is one of the harder things to do. You wouldn't do this intuitively on your own, okay? But what you need to know is if you want to change this to y over x, what you do is you take the tangent of both sides, okay? Which who would have known to do that anyway? But the reason that is helpful is because tangent is equal to y over x. Okay, and this is your answer. Okay, it's really not like a simplified answer, but you're done. You've got rid of all your r's and thetas. Does that make sense? We're in y and x form. The thing is you can simplify a little bit because you know what tangent of 2 pi over 3 is. Or do you? Okay, 2 pi over 3 is right here. Remember, this is positive, positive, negative, positive for tangents. Okay, so what's my tangent right there? Do you remember? Negative square root of 3. It's negative square root of 3. So this is negative square root of 3. And so my formula is y over x is negative square root of 3. This is really over 1. So if I cross multiplied here, I could get it into y equals mx plus b form. And what does that tell me? It tells me the y-intercept is what? 0. And it has a slope of negative square root of 3. So square root of 3, 1, square root of 3, 1, square root of 3, 1. Okay, if that makes any sense. All right. So this is the rectangular form. Okay, but you can draw just by knowing the angle. Okay. And then finally, the last thing you're going to learn today on the bottom of your paper, I think, is this right here. We're going to learn a new formula for dy dx, okay? You already knew when you had parametrics that dy dx was dy dt over dx dt. We've already quizzed on that, right? Okay, so now we're not in t parametrics anymore. We're in theta parametrics, okay? So all that means is you can replace your t's with thetas, okay? Now, what does that mean? That means that dy dx, when you're in theta form, is actually d theta of y over d theta of x. Do you agree, right? Okay, but what is your y? Because you could put y here, but it's a lot easier to put y in theta form to do this problem. Okay, so instead of y, I'm going to replace y with what I know y is, which is r sine theta. And instead of x, in theta form, x is r cosine theta. Okay. What happens is when I take the derivative of r sine theta and the derivative of r cosine theta, I get this nice formula that you could have on a formula quiz, okay? And it helps me to figure out what dy dx is for theta parametrics. All right, so let's do this. Do you guys see that this is two factors, so it's going to be product rule. Do you see that? Okay, so the way I'm going to do this is it's going to be the d theta, the derivative of the first, so it's dr d theta, times the second, which is sine theta, plus the derivative of the second, so the derivative of sine theta, which would be cosine theta, times the first, which is just r. Okay, so I did implicit differentiation. The only thing I needed the implicit differentiation on was on the first one, the dr d theta. Okay, so let's do the denominator. Here we go. It's the derivative of the first, which is 1, but then you need dr d theta. So I have dr d theta times the second, which is just cosine theta, you copy it, plus the derivative of the second. What's the derivative of cosine theta? Negative. So this sign, instead of a plus on the bottom, will turn to negative sine theta times the first, which is just r. Okay? So then what we do is if they give us a problem, so this is a formula we memorize, okay, for dy over dx. It's really not hard to memorize it because, well, actually, I write this every time, this step right here. So some students just go straight to the yellow box. I write this because I really take the derivative every time to relearn this problem every year, okay? And so it's a derivative of the first. And so the first term looks almost like this. It's just your r hops up on top of the fraction, okay? So you basically copy it, but your r hops up on top of the fraction, and it's a plus sign, and then it's, you know, the opposite of this. If this is dr d theta, this is r. If this is sine theta, this is cosine. And then the bottom, you know, looks just like this bottom, except the r hops up. And if this is plus, this is minus. The R is carried down. If this is cosine, this is sine. Okay, I mean, after a while, you'll memorize it. Okay, all right. If they give you a problem, they'll give you what R is a lot of times, and a lot of times they'll give you what theta is. Okay, so what you do is you just take every component and find the answer. So let's just take the first component, dr d theta. Okay, what is that? Well, they give you R. So it's just the derivative of this with respect to theta. Well, what's the derivative of 3? 0. What's the derivative of 2 sine theta? 2 cosine theta, d theta, right? But that's just 1. So there we are, 2 cosine theta. But do we know what theta is? Yeah, it's pi over 6. So then you just plug in here. What's cosine of pi over 6? Let me think about where that is on the unit circle. It's over here. So cosine of pi over 6 is square root of 3 over 2. Is that right, guys? So this is just square root of 3. All right, let's do the second component. The second component is sine theta. Is it consolidated? Not yet. Okay. Second component is sine theta. So this is going to be sine pi over 6. Okay. What is sine pi over 6? 1/2. Okay. The third component, that's just r. Okay. Well, for this problem, what is r? Okay, it's 3 plus 2 sine theta. So that's 3 plus 2 times sine of pi over 6. So that's 3 plus 2 times, okay, I've got sine pi over 6 here. That's 1/2. So isn't that really just 4? And then my last component is cosine theta. So that's just cosine of pi over 6. And what's that? Is that 1/2? No, that's square root of 3 over 2. All right, so I've got all these components. All you do is you take these components and you plug it into this fraction, all right? So what's dr d theta? Okay, so this is equal to square root of 3. What's sine theta? 1/2 plus, what's r? 4 times cosine theta, square root of 3 over 2. You divide all that by, okay, it's just a plug-in. What's dr d theta? Square root of 3. What's cosine theta? Square root of 3 over 2 minus, what's r? 4 times what's sine theta? 1/2. And then you simplify this. So on your test, you'll get the most credit for just putting this in, okay? If I can see your work, and then most people don't get credit for the next one because you do it wrong. So that's okay, okay? But the next problem is just really just math, okay? We just have lots of problems with math in here. That's okay. All right, we're doing calculus anyway, not real math. All right, so guys, the easiest way to do this, and you may or may not see this, is everything has a 2 on the denominator, so you can actually like divide, like multiply by 2 over 2, if that makes any sense. Like the 2's cancel with each other. They're all in the denominators, okay? If you don't understand that, then don't worry about it, okay? Do it the long way. All right, I'm really just multiplying, if that makes any sense. I'm multiplying by 2 over 2, okay? And then what this means is on the top I have square root of 3 plus 4 square root of 3, so that's 5 square root of 3 on the top. On the bottom I have square root of 3 times square root of 3, which is 3, right? 3 minus 4 is negative 1, so this answer is negative 5 square root of 3, okay? And that's how you do these problems, and that is actually what the slope of this is. It's like if you drew this picture, if you could draw this picture, okay, that's what the slope formula would be, okay? I want to look at number 11 with you guys because you have to do number 11. I'll give you guys some hints, but what they're asking for on number 11 on your homework is to find the horizontal and vertical tangent points for r equals 1 plus sine theta. Well, good for you. You already know how to draw r equals 1 plus sine theta. But I'll put this online for you so that you can draw it correctly, okay? And you don't actually have to draw for this problem, okay? I'm just letting you know that if you draw this problem, you can see how many horizontal and tangent points you have, horizontal and vertical tangent points you have, right? How many horizontal points will I have? 1, 2, 3. You see that? How many vertical points will you have? 2. All right? So I'll give you some hints on number 11. Look for that.